Hi there, this is Mr. Alexander, and today for our OnRamps calculator strategy session, I want to talk about solving equations, specifically exponential, logarithmic, and logistic functions. Solving in Unit 5 is probably the part that students find the most difficult because it requires the most algebra ability, and some students aren't as strong at algebra as others. So when you are getting into the homeworks and the problem sets and the readings and things, you're going to encounter a lot of situations where it says something to the extent of figure out when this function equals 4, or figure out when this function equals -7, or something like that. And if you're a math teacher like me, you look at these 6 examples here and you want to solve these by hand, because there's a lot of different algebraic strategies to do that. But I want to give you some options on the calculator if you're not comfortable with that. I'm going to give you 2 strategies specifically. So let's start with a fairly simple looking one, part D here. This says 3 to the power of x equals 58, and we want to know what x equals. Now if you're a math teacher like me, what you want to do is you want to take the log of both sides. You want to say log of 3 to the power of x equals log of 58, and you want to then move that x to the front, x log 3 equals log of 58. And then you would just want to solve for x by dividing both sides by log of 3. And you want to say x equals log of 58 divided by log of 3. And when I type that in the calculator, log 58 divided by log 3, you're going to end up with 3.696. Now, you didn't click on this video to watch me solve things by hand. You clicked on this video to learn how to do this on the calculator. So let me show you another way to do that. Let's just keep in mind that x equals 3.696. The first way I want to show you is my favorite, which is graphing. So if I go to y equals here, you can essentially solve any function you'd like by typing in the left-hand side of the equation into y1 and the right-hand side into y2. So if I type into y1 3 caret x, or 3 to the x power, and into y2 58, I simply want to graph these things and find the value of x where they intersect. A solution to any equation is simply where the 2 equations cross. So I'm going to graph this thing, and quickly I'm going to realize I can't see an intersection. And this graphing method doesn't work unless I can physically see them cross. So what I can do is I can change my window, and I've got to be a little smart about it. I know that my y has to be at least 58, because my second equation was y equals 58. So I'm going to pick a y maximum that is higher than 58. So I'm just going to arbitrarily choose 70, but any number greater than 58 will probably work. Hopefully now when I graph them, I'll see where they cross, and in fact I do. They cross right there. So what I'm looking for is the x-coordinate where they cross. I can figure out that x-coordinate by going to second trace, scrolling down to, you guessed it, intersect. My first curve is this one. You don't need to, but it goes a little bit faster if you move the spider pretty close to the intersection. Hit enter on the first equation, hit enter on the second equation. It's going to say guess. The way the calculator calculates this is using an iterative technique, so the closer you are to the actual intersection point, the faster it goes. So I'll just hit enter right there, so enter 3 times, and look at that, 3.696, just like getting it by hand. That's one strategy. Another one is using the solver on the calculator, which is my second favorite, and I'll explain why in a second here. To get to the solver, it's going to be math and b. Math b. You see this says 0 equals here. Well, in my equation, I don't have a 0 equals. I have a 3x equals 58. If I can get one of these 2 sides to say 0, then I can use the solver. So the easiest way to do that is subtract 58 from both sides. 3 to the x power minus 58 equals 0. Now I can use the equation solver. I'm going to type in 3 to the power of x, and this is why I don't like the equation solver necessarily, because Normally when I hit that power button, it automatically puts that x up there. So when you're using the equation solver, you need to be very careful with the parentheses. So I'm going to do parentheses 3 to the power of x, close parentheses, minus 58. And I want to solve that. If you just hit the arrow key down, it's going to say x equals some number here. And you can get the correct answer by doing alpha enter. And when you see that little black box right there, that means it's calculated 3.696. So in essence, that's all this I wanted to show you in this video, is how to do that. But let's do a few more to make sure you understand it. Let's try a logarithm. So I'm looking at this one that looks kind of nasty. Log base x 64 equals 3. What's that base going to be? What's the value of x? So let's try the graphing method on this one. To do logs of different bases, don't hit the log button here. Instead, go to Math and go to A, log base. Oops. Math A. And I want base x, and I want to put a 64 right there. And in y2, I'm going to type in 3. Since I changed the window on the last one, I always like to go back and change it to the standard window. So I do zoom 6, zoom standard. And as long as I can see where these things cross, I can get a solution. So yeah, I see them cross right there. So I'm going to do second, trace, intersect. I'm going to move that spider pretty close to where they intersect, like right there. And then I'm going to hit enter 3 times. The value of x is 4. This should be log base 4 of 64 equals 3. And that makes sense because 4 to the third power equals 64. Let's try it with the solver because the solver is a little bit different. So if I go Math B for solver, and I clear it out, I have to make it equal 0, so I'm going to say log base x of 64 minus 3 equals 0, moving that 3 to the other side. Be careful here because that minus 3 is outside of that log. So I'm going to do log base again, Math A, and this time it doesn't automatically pull up the fields for me. This is weird. The base actually goes second, so this would be 64 comma x. The base always goes second when in log base. Minus 3, and let's solve it. Alpha enter, x equals 4. So not too shabby. While I'm here, let's do this exponential function right here. So I've got 29.4 times 1.063 to the x power equals 72.3. Got to get a 0 over here. So I'm going to do 29.4 times 1.063 to the x power minus 72.3 equals 0. So that's what I'm going to type into the solver here. 29.4 times 1.063 to the x, all minus 72.3. And when I solve that, alpha enter, it looks like that value of x is 14.723. Let's do a couple more. We got time here. Let me just show you one with some graphs already on here. So it's kind of like a word problem, but it's the same idea. A bee colony's population was tracked over the course of 5 weeks. The data was modeled with both an exponential and logistic model. The results are shown in the graph below. So I've got the logistic model, I've got the exponential model. Here are the equations and the r-squareds. Looking at these r-squareds, it looks like logistic's better because the r-squared is closer to 1. It's marginally better, at least. It says, according to each model, how long did it take for the bee colony to reach a population of 850 bees? In other words, when did this equation when did that equal 850, and when did this equation equal 850? Let's do one by graphing and one by using the solver. I'm looking at this exponential first. I'm going to do that one by graphing. So I'm going to type it in. 214.403 times 1.52 caret to the x power, close it. When does that equal 850? I'm going to hit graph. I can see something over here. Looks like an exponential equation, but I don't see where they cross. So I've got to hit the window. I've got to change the window. I'm going to be smart. I'm going to know that my y max has to at least be 850. So I'm going to pick a number greater than 850. I'm going to hit 900. And I'm looking at these x's here. I'm looking at 850. It looks like this thing crosses around 3. So I don't think I need to change the x's at all. I should be able to see them intersect now. Let's just take a look and see if that actually happens. There's the exponential. And show me 850. Yeah, I can see those things cross. So now I need to find the x coordinate where they cross by doing second trace intersect, enter, enter, enter. The value of x is 3.29, essentially. And I guess that would be in weeks. So again, you could use this, you could do the algebra and solve all that, but it might take you some time, and this is quick. So, if nothing else, this is a good way to double check your work. Make sure you've done your algebra correctly. And let's use the logistic model. Let's use the solver for the logistic model. So remember, to use a logistic, or sorry, to use the solver, we got to have a 0 over here. So I'm going to subtract that 850. I'm going to do 1402.394 divided by 1 plus 6.232 times 2.0196 to the negative x power minus 850 equals 0. Going to have to be very, very careful with our parentheses here. So math B for solver. Clear all this out. I'm typing in 1402.394 divided by parentheses, because I'm going to put the whole denominator in parentheses, 1 plus 6.232 parentheses 2.0196 raised, now the exponent needs to be in parentheses as well, to the negative x power, close the exponent, close the 2, close the entire denominator, and now we can subtract 850. This is why some people don't like the solver, because of all this parentheses. So if you're not comfortable with the parentheses, use the graphing. We'll verify this using the graphing in just a second here. When I do alpha enter, it looks like it takes 3.22 weeks. So that value of x is 3.22 weeks. And I think I have just enough time to verify this logistic model using graphing, so I'm going to go ahead and type it in. Again, 1402.394 divided by parentheses 1 plus 6.232 parentheses 2.0196 to the exponent. See, now I've got that exponent up there, so I don't need an extra set of parentheses for that. Just have to close it twice. When does it equal 850? I'm going to graph it. I can see the logistic function, but I cannot see where they intersect, so I'm going to go to the window. Oh, no, I can't see where they intersect right there. Right? And so, since I can see where they intersect, let's go ahead and say second trace intersect 1, 2, 3. X equals 3.22 again, just like the solver told me. So, use graphing, use the solver. These are two good methods to solve exponential, logistic, and logarithmic equations. Anytime you need to solve, these are good techniques. To get the right answer, double check your work, whatever you need to do, this is a great strategy. Okay, thanks for watching. We'll see you again in Unit 6.